So now we're going to have a go at question 2, which is all about looking at the areas of circles and the arcs. So let's make ourselves familiar with those formulas again. So we've got area of a circle is pi times the radius squared, remembering the radius is from the center to the outside. And then if we want a slice of that pi, we do the same thing. We take the area of a circle, but then we times it by the fraction of the circle that we have. All right, so you should have got practice with that in the previous exercise. Let's see if we can employ that now. So same deal. We don't have a formula for this funky shape, but we do have a formula for this one in here, which is a square, and then we've got 2 half circles. Okay, so if I look at that half semicircle and that semicircle, if I put it together, I'm going to get a whole circle. Okay, so we're going to go, the area will be the square plus, I'll put my color back there, plus a whole circle. But what is the radius of this circle? That's the problem. We don't have the radius. Remember, the radius is from the distance from the center to the outside, and we don't have that. But if I look here, all right, that whole distance is 50, which means half of it, which is the radius, is going to be 25. So I'm going to write here, the radius is 25. Now, if that was a test question or an assignment and you didn't know what the radius was, make it up and show me that you can still work out the rest of it, even though you couldn't. So you could use the formula with the radius that you made up. But here we go. So it's going to be length times length plus the area of a whole circle is pi r squared. So 50 times 50, and watch my style, I'm going to say that's 50 squared. All right, 50 squared is the same as 50 times 50. If you wanted to write 50 times 50, that's fine too. I'm just being a little bit on the lazy side. Pi times, now your radius we said is 25, so 25 squared. Let's just see how we can do that on our calculator. Now, I'm using a graphics calculator, but it works pretty much the same way as your scientific calculator. Okay, so 50, my squared button is up here, squared. You should have one that looks pretty much like that on your scientific, plus my pi button. I believe your pi is down on the bottom row as well, so because mine's in yellow, I'm pressing shift pi times 25 squared equals, mine's going to come up with that, so let's go 2 decimal places, 4463, so 4463 point. Now 495, I said I would like 2 decimal places. Okay, so when I go 2 decimal places, you must look at the 3rd decimal. And because this is 5 or more, we have to round 49 up 1, and that becomes 50. So the correct answer is 4463.5. Now I'm going to leave it as 5. I mean, it did say 2 decimals, so I put the 0 there, but that's not really making a difference. Meters squared. Okay. Let's go on to B. I will remind you that just sort of copying down what we're writing here, that's no good. You need to have a go yourself. If you get stuck, then unpause the video and have a look. So my first question would be, what 2 shapes do you see? All right, to get this area here, we see 2 circles, and we're going to work out the area of the big circle minus the area of the small circle. But in order to do that, we need the radius of each one. And remember, the radius is the distance from the center to the outside. So if we're looking at the big one, they've told us that all the way across there is 8. So that means the radius of the big circle is 4. And then that's the diameter of the little one, which is 4. So therefore the radius of the small one from halfway mark there, okay, so from there to there, that would have to be 2. And now we just pop that in. So pi times radius of the big one is 4 squared minus times 2 squared. So please again notice what I'm writing. You really need to set out your work neatly. To the calculator, pi times 4 squared minus pi times 2 squared. Right, mine gives me that. That's okay. I press my S to D button. So 37.699. So once again, just double check, yep, we want to go 2 decimal places. So we must look at this third number here, and it's 5 or more, so 69 rounds up to 70. So that's going to be 37.7 centimeters. Okay, there we go. Onward and upward to C. We do not have a formula for this shape, but hopefully you can see we've got a quarter of a circle, or we've got 90 degrees out of the 360, which is in fact 1/4. So we're going to work out the radius of the big one once again and take away the area, the area of the big quarter of a circle minus the area of the little one. Okay, so you've got options here. You could say pi times radius squared divided by 4 because it's quarter of a circle, or you could write that as pi times the radius squared times, and remember, here's your formula here, right? Theta over 360. That's what I was just waffling about before. That if I times that by 90, because that's your angle there, over 360, you pop that in your calculator, and I mean, I'd like to think you don't even need to. You could see it, but, oh, dear me. 90 over 360, that's why we get that quarter, okay? So I'm going to prefer to leave it like this, if you don't mind. If you wanted to write it as 90 over 360, feel free. Right, so all that's left for us to do is say, well, what is the radius of the big circle? Remember, the radius is from the center to the outside. So we've got 2.5 there and another 2.5. So altogether, 5 for the big circle, quarter of a circle. And of course, the little one then, we just talked about that, that's just your 2.5. And let's make the calculator do all the work. And don't forget, make sure you've got the units squared. I'm hoping you're not listening to me too much and you're fast forwarding left, right and center there. Okay, you might recall very often you probably did that whole solid shape. You've seen that familiar from year 8. You can see that it is a rectangle plus this semicircle there. So that gives you all the green bit, but we are going to subtract the circle. So what is the formula for area of a rectangle? Length times width. What is the formula for half a circle? So we're going to take a whole circle, pi r squared, and we're going to divide it by 2. And then we're going to take away the area of a whole circle. And now it's about finding the information for each one. So do we know the length and the width of the rectangle? Yep, that's 5 and 4. Okay, for this semicircle, we need its radius. So be really careful. Once again, it's from the center to the outside. So it's the diameter is 5. Okay, so just a reminder, diameter goes all the way through, but the radius is just halfway. So it's pi times 2.5 all over 2. It says minus, I'm going to minus now the small circle there in the middle. It's a whole circle, and once again I know it's just got 3 there, but don't get sucked in. That is the diameter, not the radius. So your radius is half of 3, so minus 1.5 squared. Now if you want to, you can calculate each one separately or all at once. So 5 times 4, could have just put 20, plus press your fraction button. Pi times 2.5, you have a squared button over 2 minus pi times, oh yes it was, I remember what that was, 1.5 squared equals. Now if this was a test or an assignment, I would pop that in my calculator again just to double check. Okay, for us, you can check the answers with the back of the book to see that you are correct. So let's go again, 22.748, 22.748, and look at your third decimal. So once again, it is bigger than 5, so we're going to round 74 up 1, it becomes 75 centimeters squared. Onward and upward to E. Have a look. What is it that you see? How can we break that up into shapes that we have formulas for? I'm just going to give you a little bit of a hint here. You might already be able to see it, so then you've stopped the video and you're just doing your own thing here. But if I was to colour in these corners, right, and if I put all of those, each one is a quarter of a circle, if I put them all together, I would get a whole circle. Okay, and what about the rest of it? I could break that up. Okay, I've got a rectangle there, which is 5 by, what is this one? Now that's 3. They're telling me that that's 1 unit and that's 1 unit. So that means my area is going to be 5 times 5 plus this whole circle, and what's its radius? Right, from the center to the outside, times 1 squared. And then I have to add on this area and this area, and you can see pretty easily that that has got length 3 and width 1, but there's 2 of them, so it's going to be, you can either say 3 times 1 plus 3 times 1, or you could just times that by 2. Okay, and it's off to, oops, no, not yet, and it's off to the calculator you go. Pop that in, see if that works and it's the right answer. So again, stop the video, you have a think about F, and then unpause to check. Just going to get rid of this to give us a bit of space. How are we going to get this shaded area here? So that's a funny shape. It's not part of a circle there. So what do you see? If we look at the big, that is quarter of a circle there. Okay, so we're going to work out that area for quarter of a circle. And then if you work out the area of that triangle and take that away, there, you will then be left with the green bit, which is what you wanted. So again, quarter of a circle, it's going to be pi r squared. To get a quarter of something, we're going to divide by 4, or times by 90 over 360, which we've said before is a quarter. And we want a half base times height. The only thing that's stopping us, do we know the radius of this? Well, here's the center to the outside. Right, picture that's the circle going all the way around. Right, so that's our center of the circle to the outside. So the radius is 15. 15 squared, don't forget to square it, minus, if we look at that triangle and sort of tilt your head a little bit, maybe that's the base, and then there's your height there. So it's a half times 15 times 15. And off to the calculator with you. Remembering to pop meters squared. So check, if you don't get the same answer, we can go through it in class. If that's just a calculator error, you can check on how to use our calculator properly. Okay. How about G? Might change to the pink so you can see it, because I'm going to draw on the diagram there. So I'm going to leave this one for you, but it is still this bit here. We've done questions like this, I think, because that is a fraction of a circle. You just have to figure out what fraction is it, right? How many degrees is that all the way around? Now we know there's 360 degrees in a whole circle. We've used up 120 there. So we've got 240 degrees left. So we go back, we double check, oh yes, this is the sector. Now instead of being the little sector, we've got a massive sector there, so your theta is a big one. So we're going to write that down. I'm going to say pi times radius squared, times theta over 360. So pi times, what is the radius? There it is there, it's from the center to the outside. So times 18, don't forget to square. Times, now what fraction of the circle do we have? We just worked that out before, it was 240 out of the 360. Let your calculator do everything for you. And we'll just finish off the second to last one. Okay, hope you can see we have a sector, and then we're going to minus the square. So again, pi times radius squared minus length times width. So we need 2 bits of information to work out this whole sector. We need the radius. So there she blows from the center to the outside. So pi times 9 squared. And theta, your angle here, is 50. What are your dimensions of your square? This one here, 2 by 2. Off you go. Now, you don't need to do, it's in red. It's pretty much the same as the one we did in F. The only problem is this isn't 90 degrees. I hope you know what it is, because we've got all the lengths are the same, which makes that 60. The problem, and the reason why you can't do it at the moment, is because you don't have the vertical height. Now you can get that once we've taught you Pythagoras, but that's coming a little bit later in the term. Right, so that's question 2. I hope that's helped. And if you get stuck, you can either come back to the video or you've written this neatly in your book to help you.